Welcome to another video. In this video, we are going to learn very basic concepts of transformers. This tutorial is oriented specially for the students who are looking for short questions answers regarding transformer. So let us start the video by discussing why we require transformer. Then why it is called transformer? What is the working principle of transformer? Then we will briefly see different parts of transformers, and based on this we will also discuss different types of transformers. The most important topic of these transformers are the classification, application, and the specifications of transformer. So if you haven't subscribed to our channel yet, please don't forget to subscribe and like the video. So let us start by discussing why we need transformers. The transformer are the basic component for the transmission and the distribution of electricity in power system. So why we need transformer in power system? Normally, the transformer is used to increase the voltage at the power generating station, and this is called the step-up transformer in order to minimize the transmission losses during the transmission of power. And then it will be used to step down the voltage at the distribution level to supply power to the household or the commercial industrial users. Other than this, there are different appliances that are manufactured in different countries which have different voltage level. In order to operate those appliances, we need to make a voltage compatible with these appliances, and that we can only do with the help of the transformer. So what is transformer and why we name it as transformer? Basically, the transformer comes out of the transfer or transform. So what does this device transfer? It transfers the electrical energy or the electrical power at different voltage levels, and it transforms the voltage, and because of this the current in the windings also transform. That is why we name it as transformer. And transformer is a static device. It means that it has no moving parts in it. Unlike the motor, it is a static device. As I've already told you that it transfers the electrical energy from one part of the electrical or electronic circuit to the other part of the circuit without changing the frequency. There are two windings. Both windings are not electrically connected but magnetically connected. And when the secondary winding is connected to the load, the electrical power is transferred from the primary winding to the secondary winding to energize the load. And it works on the principle of Faraday law of electromagnetic mutual induction. So here we discuss the brief history of the transformer. That is, the first transformer was ever developed in 1885 but was commercially used in USA in 1886, and the design was invented by William Stanley. So let us discuss the basic principle of the transformer. The transformer works on the principle of electromagnetic mutual induction. So what is mutual induction? As there are two sets of windings in the transformer, the one is called the primary winding and the other is called the secondary winding. When we energize the primary winding, or when we supply voltage to the primary winding, and due to which a magnetic flux is created, that flux links with the secondary winding through the help of core. The core, as I have already told you, is used to transfer the flux from the primary winding to the secondary winding. And as per the mutual induction law of Faraday, whenever a conductor is placed in a changing magnetic field or magnetic flux, there is an EMF induced in that conductor. So whenever we connect a load across this secondary winding, there is a current that starts to flow in the secondary winding. So this is how the power is transferred from the primary winding to the secondary winding up to the load. And the voltage induced in the secondary winding is according to this formula, which is Ns d phi over dt, where Ns is the number of secondary winding turns and d phi over dt means the rate of change of magnetic flux. So greater the rate of change of magnetic flux, greater is the voltage induced in the secondary winding. So let us discuss the basic construction of the transformer. Normally, the transformer consists of the core, which is laminated. The core in the transformer is constructed by assembling or stacking laminated sheets of steel with minimum air gap between them and then laminated in order to reduce eddy current and to maximize the permeability in order to maximize the flux linkage to the secondary winding. There is a winding which can be made of copper or aluminum coated with very thin layer of insulation, which has a temperature class and the insulation class as well. Then comes the conservator. It is to store additional cooling oil. Breather is used to absorb the moisture content from the air whenever the air sucks in while the oil get expanded or contract. Then the Buchholz relay, or nowadays we also use electronic relays in order to protect the winding from overheat, and the circuit will be tripped off as soon as the coil attains a predetermined temperature or preset temperature. Now we will discuss different types of transformers. The transformers has different types based on construction, the type of windings, and the type of cooling method. On the basis of construction, it is classified into core type transformer, shell type, and the spiral core transformer. Similarly, on the basis of windings, the transformer can be a step up transformer, step down transformer, or the isolation transformer. And based on the cooling material, it is either oil filled self cooling, oil filled water cooling, oil filled oil cooling, or can be a dry type. Now we will just go through all these terms very briefly. First is the core type transformer. Here you can see the core and it has two limbs and the windings are wounded on the two limbs of the core material. Then comes the shell type transformer. This core has three limbs. Both windings are wounded on the central limb on one another. And then the spiral core transformer, and this is constructed similar to the wheels of spokes. So on the basis of winding, the transformer is either classified into step up transformer or the step down transformer. So what is step up transformer? In step up transformer, we step up the voltage, that is the applied voltage or the primary voltage level is low and the secondary voltage level is high. In this transformer, the number of primary turns is less than the number of secondary turns, or you can also relate this relation directly with the voltage, that is primary voltage is less than the secondary voltage. In step down transformer, the primary voltage is greater than the secondary voltage. And in other terms, in terms of the turns, number of turns, the primary turns are greater than the secondary turns, and same relation also holds for the voltage. Now on the basis of coolant, this is normally applied in the small and the medium size distribution transformers which you normally see around you. The assembled windings and core of such transformers are mounted in a welded oil steel tanks provided with a steel cover. The oil help in transferring the heat from the core and the winding to the case from where it is radiated out to the surrounding. So this type of cooling use natural air in order to cool the oil, and thereby cool the windings and the core. The another type is oil filled water cool. It means that the oil is filled in the transformer and the water is used to remove the heat from the transformer. So the oil carries the heat of the winding and the core, and the water, which is cooled by means of cooling tower or chiller, is used to remove the heat from the oil by means of heat exchanger. So this type is normally used for the more economical construction of large transformers. And then the third type is the dry type that utilizes air cooling method to reduce its working temperature. So where we apply the transformer, main and the most important application of the transformer is in the electrical power systems, where it is used to transmit the power at high voltage level, and then it is used in the power substation to reduce the voltage level for the customer. Also, these transformers are used to regulate the voltage. Whenever there are fluctuation in the voltage, we use different taps of the transformers to stable the output voltage. Nowadays, almost in every electronic circuit, we need a transformer because all the electronic circuits work on the voltage level of 5 volts, 12 volts, 24 volts, etc. These are the very basic specifications of the transformer. The first is the power rating. It must be in the VA, kVA or MVA. Then we have to specify number of phases, either 1 or 3. Then the frequency. This is very low frequency, 50 or 60 hertz. Normally we have now very high frequency transformers in order of kilohertz or megahertz. Then primary winding voltage, it could be anything. Secondary winding voltage. Then we have to define or specify number of taps. Then the connection type, this is very important. DYN11, it means that the primary is delta and the secondary is star with a neutral point. Then the type of cooling, whether it is oil type, dry type, and then type of tank, whether it has a conservator or it is sealed without a conservator or the breather. So I hope you have learned much about the transformer in order to properly answer the very basic questions regarding the transformers. I hope you like the video. So stay tuned and don't forget to subscribe our channel. Thank you for watching.